In this video, we're going to go over using Insight 360 for energy analysis, and we're going to do it on a model that's built up of building components. So it's already been developed beyond the point of conceptual and massing. It is walls, roofs, floors, and rooms, windows too. So with this model, what we're going to want to do before you do anything else is, for one, we're going to get into the model, but two, you got to always make sure your location and your true north are set correctly. In this case, this building is in the right location, right up here. And if I go to my site plan and set it to be true north, that is correct. And if that's not correct, what you would do is come to your positioning and rotate true north to the correct location. When you do it, you just get this from your origin point. You can click and turn a certain amount of degrees, and you can type in, if it's 60 degrees, you can just type in 60. I'm not going to rotate mine now because mine's already correct. So that is how you can rotate true north. So you want to make sure you have that set up. Otherwise, your analysis is going to be meaningless because it's not how your building actually is. So the main time that you're going to spend on this is getting the model ready, making sure your rooms are all correct. This actually takes quite a while. So in this case, if I go to my ground floor, what I want to do is check and make sure all my rooms are placed. Just because they're not tagged doesn't mean that they aren't placed. So quick ways to do that throughout your model is you can just turn this on temporarily. You can go to View, Visibility Graphics, and type R to get down the rooms, turn rooms on. But you also want to make sure you turn on Interior Fill. This isn't typically on. Turn that on, and you're going to see the blue fill of all the rooms. We're going to ignore the closets right now. You could put rooms in there too, and especially not these ones. These ones are on the inside. They're not doing anything. So you want to make sure your rooms are covering pretty much all your footprint, hitting all your walls correctly, not getting stopped before they hit a wall. So in plan, this is reasonably correct. If it's not, what you do is you would come. So let's say you were here, and this room was not here. What you would do is come to the Architecture tab, go to Room, and place the room. And hit Escape before you place another room. Then you can label the room by clicking on the label. But first of all, let's make sure all our rooms are have the right height too. This is a volume exercise, not necessarily an area. So to make sure you're even calculating the volume, you want to go to the Architecture tab and then go to Room and Area and click down, and we're going to do Area and Volume computations. And we're going to, by default, these are your settings. We want to make sure we're doing volumes. And I'm going to leave it off right now just to show you what that means. So to check this in section, what we would do is create a section. So go to View, Section, and I'm going to cut a section through here. And this is just a little working section. So I'm going to flip it. This is going to help us see what our rooms are doing. And right now you can't see the rooms like we can. You can click on them, but you can't see them in the plan. So we're going to do the exact same thing we did in the plan. We're going to turn on Visibility Graphics. Type R to get down the rooms. Expand rooms and turn on Interior Fill. And you can see that we actually have some problems of rooms hitting each other, being on top of each other. This one's actually going through a floor and through a roof. So that's all a problem. So what we're going to do is a few things. We're going to go back to the Architecture tab, and right where I showed you area, room and area, if I turn on area and volume computations and do area and volume, okay, you'll see that that room actually cut itself down to this floor. Why did it do that? It did that because if I select this floor, it is room bounding. you'll see your floors, walls, and roofs, and ceilings sometimes can be room bounding. And that's what you want. If that was turned off, it would not stop that. Yeah, it's going to go all the way up to the roof now. So what we want to do is keep that on, keep that room neat. The other thing is you're seeing that these rooms are not tall enough for this double height space. So what you want to do is hit tab until you get the room where you get that X across it, and you can drag it right through the roof. And it doesn't matter if you go through the roof because the roof is room bounding and stops it at that level. We're going to pull this through. That way it's engaging this roof, and that's now part of this analysis. So the neat thing about using one of these little sections to define this is then you don't have to make a bunch of them, you just move it. So I'm going to grab my section, move it here. If I double click on the head, it takes me to that view, and we can see what's happening. So I'm going to hit tab a few times, get this room, pull it on up. And that looks good. Go back to my ground floor. Make sure I hit that little powder room. That looks good. And go all the way to the bathroom and the last room. And we need to adjust this one. That looks good. So now our rooms are not overlapping. They're stopping at these bounding elements, and it's making everything much neater and better to analyze. This used to be very important in Green Building Studio 2, which still exists. You could still use it, but Inside 360 gives you more of an adjustable, let's see where our savings can be interface. So this is good. We have all that set up, and our building is pointed in the correct direction. Our rooms are correct. We've built up our walls and floors and everything to be what we want them to be. So now what we have to do is we have to try and sign in to Autodesk 360. And once you sign in, you will find it typically changes your username to match. It's okay. But now I am signed in. So now what we want to do is go to your Analyze tab, and you should have this Insight 360 tab here. If you don't, what you want to do is, it's a free plugin, so you can Google Insight 360 download. You'll come to a page that looks like this, and then you download it for whichever versions of Revit you have. You can download it for several different versions, install it, and it plugs right in to Revit. It shows up here. So first off, let's click on our energy settings to see what our settings are for this project and make sure they are correct. Make sure your ground plane is at the right location. In this case, we are using building elements because we are beyond the conceptual masses and we are not using a mix of the two. So we're just doing building elements. And then under advanced, we want to make sure we have the right building type. Building operation schedule, this is how many hours of each day this is. By default, it'll pick one for single family, what that is. It has a heating system here, heating and cooling system. What you want to do is try and pick one that is close to the correct size as what you're going to be using. In this case, I'm going to pick this residential one. But it's very hard to get the correct selection here, and it also doesn't always have all the different sizes that you might be using. So what you really want to do is keep this consistent between your models. That way, when you compare different runs of this, you can see that this remains the same, but your geometry might have made a difference. You can add in more detail if you want to. We are exporting the rooms. You can do conceptual types. What this does is it lets you pick the types of construction that you're working with. So for the exterior wall, these are all terrible names. They really are. They could actually just say R13, R19, and you'd have an understanding of what your insulation is. But right now they have this, which is not so great. It's a little frustrating. But definitely for your glazing, there's no coating stuff anymore. It's almost always double pane, low E. So we're going to pick cold climate. And we're going to keep most of this pretty similar. So we'll be able to look at the roof assemblies when we get into the Insight. So hit OK. The schematic types, again, this is showing us a little bit more about what it's assuming its construction is, and this is where we can adjust a little bit. So we can see there's the U values. Let's see, probably going to be wood frame. Doesn't matter, ceilings. Yeah, so these are better guesses here, but you can adjust the analytic construction in here to work with the systems that you're selecting. So hit OK. All right, detailed elements, don't turn that on. What that is if you've built all of your walls and have thermal properties for all the, here, I'll hit OK, so you can see what I'm talking about. If you click on this roof, it's going to have material properties to it. And so if I edit those and go into the structure, see, these materials don't have any thermal value to them, so when it adds it up, it's still getting a 0 R rating, resistance rating. So that's why I was saying, unless you have very specifically set up the materials for thermal properties in your project, this isn't the way to go with a detailed. It's better just to go analytical right now until we figure out a little bit better what we want, and then we can take another run at the model. So, okay. All right, so now that's done. We can generate. So let's hit generate. Update the energy model. Okay. Okay. And then we'll click on optimize. And this takes you to the Insight 360 website. So right now you'll see that this is analyzing in process. So you can, this is in the cloud, it's going to run. I'm going to stop the video for a minute just until it's done running. It can take 5, 10, 15 minutes, but this is it running its analysis. And then what we're going to do is we're going to see what we come back with and then tweak it a little bit to see if we can make it better. All right, so that took a little bit more like 20 minutes, but now this is complete. Before we jump in, sometimes it's good to come here, and that's not really what I was looking for. Let me see. All right, we'll jump in first. All right, so it comes up a little surface pattern of how much of all the different surfaces we're talking about: walls, roofs, floors, shading devices. It's showing as much as it can here. So sometimes you will see how messed up this little web portal actually in Revit can get. So you can see how I can't see all my buttons or do anything over here. the way I've found to fix that is just to go to it through the actual website. So if you go to insight.autodesk.com/OneEnergy, you can actually log in. And I'm going to log in here. So I get in here and it's going to show up under my uncategorized projects. And it's this lake house. One thing before I jump in, this is what I was kind of looking for when we were in the actual interface in Revit that I didn't see, is you want to find this little gear, because a lot of times it starts off in metric, and meters squared doesn't matter as much to us in the States, so let's do imperial, and then hop in. And now we can actually see all of our little widgets down here. All right, so just so you can see what's happening up here, what this is how many US dollars you're spending a foot a year. Now it's kilobyte a BTU per square foot a year. So what I would do is stick with the BTU one and not the dollars, because the dollars, what that means is if we're in Montana, it's just going to look cheaper than if we were in New York, based on the energy costs of the location that we have selected. So it's always just good just to look how many BTUs per square foot are we talking about here. And then we can try and find out where we are on the realm of this building. So this is how Insight 360 works. You can play around with these widgets, and what you're trying to do is lower the amount of BTUs you're using per square foot per year. So right off the bat, this is a pretty efficient house based on the settings we have. See, right now it's landing here, and it's right between ASHRAE 90.1, which is a pretty good standard. That's your baseline for commercial buildings, institutional buildings, and energy use. And it's between that and the Architecture 2030 promise, which is very low and very little energy use. All right, so I can show you how to use some of these pieces. They're all just little widgets. They tell you on the front what they are. But the nice thing is you can flip them around, and what we're seeing is wherever the triangle is that is basically where the geometry of the model is. So for this one, if we look at it, there's very little change based on the orientation of the building. Very little, which is interesting. It just helps you to know that turning this building around doesn't make that much of a difference. But what we want to do is refine it down to just where we were looking at. So it didn't make a difference on that one, but it will on other ones. So because what it's doing is it's giving us a range of what its energy could be. So let's look at the window to the wall glazing. So what this lets me do is on the southern walls, what difference does it make depending on how much glazing I have? So in the BIM model, if I hover over this, I have about 30% glazing on my southern wall. If it goes down to 15, what does that save? So let's see. Let's see if we're just thinking about 30 or less. And you can see this went down a little bit. It went from 145 to 143. So if you want to reduce down to zero glazing, you can see it's going to save you about 3.5 kBTUs per square foot a year. But in this case, we're probably going to stick with the model. We want some southern light. So I'll narrow it down to that. Window shades. Well, how much would they save me? This building on its southern side already has some overhangs, so you can see it's already on a pretty low end of the spectrum here on how many BTUs are saved. But what we want to do is move it to that, because then we don't see a range anymore. All right, window glass on the south. Does that make a difference? Again, we're pretty flat. So we are pretty flat. We could save a little bit. Let's see, yeah. So we probably want that single clear, double clear, triple low E, and double low E. So if we wanted to do triple glazed glass, what we would do is on just the south side, make that adjustment. You can see this going down already. So we knocked off some more energy use just there. So now we know triple glazing makes somewhat of a difference. Let's see. So the window to wall ratio on the northern walls does make a little bit difference. You can see this line move a little bit. And again, we're not going to see huge movements unless it's maybe in the HVAC system. But let's narrow this down. And again, you see we're going down a little bit more. We're getting a little more refined. Window shades on the north really isn't going to do anything. Yeah, we're pretty flat all the way across. It doesn't save anything because we're not really getting direct light. Window glass on the north, again, not a lot of difference that it makes, but the triple low E does save a little bit. It saves us another BTU, so let's take it. I mean, I know triple glazed glass is very expensive. Window to wall ratio on the western walls. I'm again going to just stick with our model right now. There is savings to be had if we go down a little lower, but we're going to stick with our model. Window shades on the west, will they make a difference? The BIM, let's see, if we ever go negative, not a whole lot, not a whole lot. So what you see, this is letting you make conceptual moves and see how much energy you can save. So the west walls, let's go to the triple glazed window again. We go down a little bit. Again, those triple glazed windows are saving us a bit of money. We're not really, you can also say on the eastern walls, it's a significant savings if you reduce windows on the eastern wall. So you can actually see this line going from 95 down to 0. You can see it sloping quite a bit. I'm going to get us down to our designed intent. And you see that saved a lot. That probably saved. So eastern walls is probably something that we want to really look at. And maybe the window shades on the east. Let's see if they save. They would save us a bit. They would save us a bit if they were 2/3 of the window height. I'm going to again keep to my geometry, but we can look into getting some shading on that side. And then the eastern side, the eastern glass. So let's see, we'll do the triple OE again since we're doing that everywhere else. That saves a bit. All right, so now we're out of the windows. We're into wall construction. So current setting is uninsulated. I didn't think that was uninsulated, but okay. So this says what you can make your walls out of and how much that saves. So yeah, it's not uninsulated. It's just ranging from uninsulated to what we had. So R35 is pretty high for a residential home construction. That would be a thick wall. Here's a 12.5-inch SIP panel, 14-inch continuous. So you know, somewhere in here probably. Let's go for R13. That's very basic frame, but you see that saved some money. We dropped down. So you can look at your R values and what you want to do. Roof construction. This is some savings here. Because I guess I thought my roof was uninsulated. All right. So if we went with a R38, which is more doable on a roof because you have deeper rafters. Let's go with R38. Let's see if this drops. Oh yeah, that dropped a lot. So again, this is showing you exactly where you could save your money just by all this air infiltration. This is just how tight you make your building. We might not say we're not doing a super tight building. I can leave it the full range. Well, let's at least get it down in here. How many air changes a minute? So if we get it to almost passive house levels of 0.4 air change an hour. Again, we're dropping down further, so we're doing good here. Lighting efficiency. It's a single-family home. We had that set up, so it's about it will match what we had set up. Daylighting and occupancy controls. It doesn't look like there's a lot of savings here. We're zeros, more or less. Well, you could say half of one if there's daylighting occupancy control. So I'll leave that as is. Plug load efficiency, we'll skip. HVAC, let's see if there's a better system than what we had. The one we picked out was pretty good. There's a high efficiency heat pump that would save us a little bit, and an ASHRAE heat pump. But you can see the VAVs just aren't nearly as good. They're just a lot more energy. So let's do the ASHRAE heat pump. And that knocked us down a bunch. Wow. Wow. We're really getting low on this now. Operating schedule. As it is, I think so if we're 12 hours a day, 7 days a week, we're home half the time. That's what we would do. We don't have PV panels, but this is something you can look into to generate energy of how much of your roof is covered with PV panels. So this is something to look at when you're trying to generate energy and what you're imagining doing. And here's the surface coverage of your PV panels. So you could pick out the panel efficiency, and then you could pick out the surface coverage, and just see what that does. But right now, with just those adjustments, we are doing pretty good. I mean, if ASHRAE 90.1 is at 253, we are at 49. We are doing very well. This is not using that much energy. It's still above it's still well above the ARC 2030 challenge at 13.7, but you can see we went down as we went through all of our adjustments. We made a big drop at the HVAC units. So what this does is it lets you test your model early on and go through every little piece. And some models, depending on what you have built, you might see a sharp change in any of these angles or any of these graphs. And that's when you know that's where you could save money. So just here, roof construction is clearly very important. Same thing with infiltration and wall construction. You can actually see that those are very important for saving energy here. And if I go back down, same thing with the HVAC. I mean, the HVAC, these are massive amounts of energy. So this helps show you with the geometry that you've designed where the most bang for your buck can be. So what you might want to do next is just get some of this information out of here. Obviously, you can screenshot this. That's not that terribly useful. But these charts really do show a lot of information of what your decision making is based on when it comes to your energy, and what you're seeing is making a lot of bang for your buck. So a very kind of simple way to export would be go to generate, back to Insight, and if you click on these dots here, you can export. And I normally select all and hit export, and it'll generate a little zip file. And what this will have in it, it'll have some data that you can put into other energy analysis programs. It'll also have little PNG images of all of those charts, so you can take them and arrange them how you would like to make your presentation. So it takes a little while to compress, but once it does, it should just download. And you have a zip file. There we go. We have a zip file that we can open up, and in there you would see all these little PNG files that you can open up and put on some documents, show your thought process. And then you also have these other energy settings that you can bring into other programs for analysis. And that's the basics. That's the basics of running through Inside 360 and how to take an early Revit model with components built up and test a lot of very conceptual pieces that can reduce energy to try and get yourself as low as you can in the range you need to be. Obviously, you need to be under ASHRAE 90.1 or you're not meeting energy code, but let's try and beat it as much as possible.